If you have used a CAD platform like Onshape before, you might have done something like this. Click Extrude, select a 2D sketch, and extrude it into a third dimension. And what we have here now is a solid. What you might not know is that Onshape, just like a lot of other CAD platforms, doesn't actually think of this as a solid, but instead it's what's called a B-rep, or a boundary representation. In other words, this part one that I have here, which now encloses a solid volume, and I can apply material properties so it'll have mass. What's really going on is that this part that I have is a solid volume represented or bounded by a bunch of faces or surfaces. So when I clicked my 2D sketch and extruded it into 3D, really what I did was simultaneously create 6 surfaces. And you can see that this rectangular solid, this rectangular prism, is actually just a volume enclosed by 6 surfaces. And you can see the difference if I were to say, actually I don't even have to click a sketch, I could actually just click this face here and say delete face. If I delete this face, Onshape doesn't create any errors, it just says, okay, we now have, instead of 6, we have 5 faces, all one enclosed or connected surface, but it's missing the top, so I don't have a part anymore. So I used to have a part, and the reason I had a part is because I was enclosing some solid volume. But now that I'm not enclosing a volume, I just have a collection of surfaces or faces. Now I can undo that, and notice I go back to having a part and no faces, or no surfaces. So if I were to sketch on this top and maybe draw a circle, I could split that top face with that sketch I just drew, and then delete just some portion of that top face. That's enough to turn my solid into a bunch of surfaces, or into, in this case, one surface, because they're connected. So it's important when you're modeling to realize that when you are creating solids, like a lot of us do when we start using CAD, we do extrusions and revolves and sweeps and lofts. Really what we're doing is creating surfaces, and if those surfaces enclose a complete volume, then we have a part. So let's take a look at a couple more examples of this. So again, instead of extruding this as a solid, I'm going to this time extrude that same sketch as a surface. So I'm going to take my rectangular sketch and extrude it just like I did last time. But if I extrude it as not a solid, but as a surface, Onshape will just take those 4 lines and extrude them into 4 surfaces, or 4 faces, which enclose or create one surface. So I've got 2D surfaces that are bounded by lines on which I can draw points. So if you've taken a basic geometry class, you might be familiar with a point and then a collection of points called a line, a collection of lines called a plane or a surface, and a collection of surfaces can create a 3D volume. So when you're drawing complex geometry in Onshape, sometimes it's important to be thinking about really what's going on under the surface, and that you're creating boundary representations. Now you can see I have just a surface here. Now I can use some of my surfacing tools, which a lot of people are not familiar with, to create a solid shape or a solid volume. So I'm going to use the fill tool, which is a very powerful tool. And in the fill tool, if I just select enough edges or curves that completely enclose a plane or a surface, Onshape will create that surface there. And now I have my surface now has 5 faces, but it's still not a part yet because I need to enclose that last top here. One way to do that would be to do another fill. Let's try something like a loft. I can actually loft between 2 edges, and Onshape will quickly create a surface there. Now notice I no longer have a surface, I have a solid part. That is a solid enclosed volume that I can, again, add material properties, and I'll have a part. Now, why would I care about doing that instead of just doing a good old extrude? It's really because when I'm trying to create a little bit more complex surfaces or complex shapes, especially smoother or more organic looking shapes, a lot of times this becomes really useful. So if I were to create a new sketch on this plane and maybe use a couple vertices here, I can actually create a spline, and a spline is a great tool for creating organic shapes, and maybe give it a little bit of character. I like that shape there. I can now go back and, just like I did, use a loft to loft between those two edges, and I've got a solid part. But this time I'm going to give my loft a guide. I'm going to use that spline I just drew. And now what I have is a part that looks a little more organic and swoopy and smooth than I would be able to create with just the typical extrusion and fillet and those 3D modeling tools or solid modeling tools. And so you can see that Onshape has created a nice shape that would be pretty difficult to create using those normal solid modeling tools. So there's a good example of how I can take advantage of the fact that I can create a solid part using my boundary representations, and my boundaries can be some pretty interesting surfaces. And before we move on to the next example, I'll just mention that another way to create a solid enclosed volume is to use thicken. And so I've extruded my surfaces here, and with one step I can just say thicken all those 5 millimeters, and I'm back to a part that is a solid part enclosed by a whole bunch of surfaces that Onshape has created for me. Okay, and then of course the last way that we can create another way we can create solids is using the enclose feature. So let's go back to here. I'll get rid of thicken, and so now I've got this enclosed box, and maybe I'm going to create a plane on. Let's see. I'll do a 3-point plane here, and if I use 3 points here to create a plane, I didn't create 3. There we go. There we go. Now I have a plane. Now I can use enclose, which is under the thicken option. And if I use that surface, the surface that I have that's 5 faces, and that plane, that will create a solid part. And obviously that plane could be offset or something like that. And I've now created a solid part using enclose. Now let's look at one final example. Say I've got my same old rectangular sketch. This time I want to create a solid that is about the same dimensions. So in other words, a solid is about 200 by 100 and 100 tall. But I want to guide the surfaces to create a really organic shape. So what I'm going to do is I'm going to create a loft, but in order to make that loft, I'm going to make some profile sketches. So you might know that a loft creates a surface or a volume between profiles. So I'm going to sketch some nice profiles that are nice and tangent at the top and nice and smooth curves. So when I create this loft, I'll have a shape that again would be pretty difficult to create if I were using just extrudes and fillets. So that's a nice organic looking shape. And also another modeling technique that a lot of people use is if you have any symmetries, it's a good idea to take advantage of those symmetries when you're modeling. So I'm just going to mirror that shape. I'm going to mirror it one more time. Let's see, I'd like to do an add, so I just end up with one surface. And then I'm going to mirror that one surface across this plane, and I've got a solid surface. Now I'm going to do an enclose like I did a second ago with that surface. I'm going to enclose with that surface and my bottom plane, and that should create a solid. Let's see, face. I'm going to create this. Oh, I created 2 surfaces again. So I need, in my mirror, I need to make sure I use an add. So I've got one surface. Then I can use enclose and that plane. And I should have a solid part. Now I have a solid part. So there it is. Again, a kind of fun organic shape. I'm going to mirror one more time. I'm going to do a part mirror. I'm going to mirror that part again over this plane. And now I have a solid that is roughly 100 by 200 by 100 tall, and that's what I was looking for. Now, notice if I look at the shape that I've created here, it's a little bit bumpy, and I want to see if I can fix that. So again, I'm going to take advantage of my loft, the fact that I can use guides and things like that in my loft. And now would be a good time to mention that when you're creating solid geometry out of surfaces, your solid geometry is really only as good as your surfaces, and your surfaces are really only as good as your sketches. And so that's a good thing to remember, that when you're creating solid geometry from curves and surfaces, make sure you've got good sketches and that are tangent or curvature continuous where you want them to be. So I'm going to use some guides for this loft. If I just use these 2 guides, that right there will make a much better surface. That's basically what I was looking for. That's a good looking kind of football shape. I might even turn on some kind of curvature analysis like zebra stripes to see how my shape is doing. I can see here at the nose, it's really continuous. So I've got no discontinuities or abrupt changes in my surfaces up here on the nose. Now in the back, I can see there's a little bit of discontinuity. That probably is coming from my loft again. And so my start profile, which is that one on the far right, if I start that normal to profile, that should smooth out that shape right at the beginning. And then when I mirror it, I've got nice continuity. So I've created a good looking shape. And so if I turn off zebra stripes, I can see that I've got a really nice smooth shape here that I've created, again, similar to using extrudes, but I would be really hard pressed to be able to make this fun shape using just extrudes and fillets and things like that. So what can you do with that? If you want to create organic shapes, this is the process you're going to want to use. You're going to want to create some nice sketches using splines, Beziers, conics, and curves. And then you're going to want to create surfaces, take advantage of symmetry where you can, and then enclose or thicken or fill where necessary if you do eventually want a solid part. Just as a quick example, I've imported a sketch into a couple sketches into this part studio, and I've used the geometry there to trace some of these nice curves, these nice organic curves, and then I'm going to use things like a projected curve. And a projected curve is a great tool that really is the intersection of planes. And so I can see that I've taken one of the profiles that I sketched from the top, and I've extruded to this plane, and then one of the side profiles I've extruded, and what the result is this curve along this edge, which projected curve means you don't even have to make those extrusions. Projected curve will make that for you. And then I've started using those, just a couple projected curves. You can see that I've started to create what might eventually become a car body. And that's just couple projected curves and a few lofts, and that's it. And then I used an isocline here because I'm going to start chopping up this surface into the headlights, I think is what I was using there. And then just using a few more features. I only have 45 features. I've created a car body, and then I've enclosed it and thickened it, and eventually using this, I can 3D print this and stick it on top of a model that I'm creating to make a car for competition. So that's just your basic introduction into B-Rep and surface modeling. And just remember, your solids that you create using curves and surfaces are only as good as your curves and your surfaces. Thanks.